Hi girls. In this lesson we're going to look at higher degree polynomials, which means polynomials of degree 3 or more. All polynomials are continuous, which means we can draw them without lifting our pen or pencil, and they're smooth, which means that they do not have any sharp corners. So for example, this would be a polynomial function because it's continuous and it's smooth. This is a function, but it's not a polynomial function because it's not continuous. This is not a polynomial function because it's not smooth. It's got a sharp corner. Okay, one of the first things you need to know about polynomials is the leading coefficient test. So all polynomials are in the form of a sub n x to the n power plus as many terms as you need in between, and then a sub 2 x squared plus a sub 1 x to the first plus some constant a sub 0. So if n is odd, meaning that your highest degree term has an odd exponent, then your polynomial is going to either go like that with all kinds of stuff happening in between, or it could go like this with all kinds of stuff happening in between. Basically, if it's odd, the end points on the right side and the left side are going to be going in opposite directions. So if the left side's going up, the right side has to go down. And if the left side's going down, then the right side has to go up. If n is even, then both endpoints are always going to go in the same direction. They're either always going both up or they're always going both down. So that's the leading coefficient test. So how do we know if they're going up or down? Well, that happens to be determined by a. If a is positive for an even function, then it's going up. And if a is negative for an even function, then both ends are going down. With the odd function, this one is a greater than a sub n greater than 0. So in other words, it's increasing as you go from left to right. If it's decreasing as you go from left to right, then your lead coefficient is negative. Okay, all of these statements mean the same thing. X equals a is a 0 of f of x. X equals a is a solution of f of x equal to 0. X minus a is a factor of f of x. And a comma 0 is an x-intercept of f of x. All of those things say the same thing. Namely, that if I've got a polynomial and it's crossing the x-axis at a comma 0, I can say that a is a 0, a is a solution when the function is equal to 0, or x minus a is a factor of the polynomial. Well, if you have a factor f of x that is x minus a and is raised to the k power, and k is more than 1, for example, let's say k is 3, so we might have x minus a to the third, then it's going to cross the x-axis. So let's say that a is right there. Then it's going to be going right through the x-axis like that. Okay? But if k is even, say x minus a is squared. So here's a right here. What happens is it's just tangent to the x-axis. It touches it at just that one point, and then it turns around and goes back up. So it does not cross the x-axis if k is even. We say that this factor has a multiplicity. This factor has a multiplicity of 3, and this factor has a multiplicity of 2. Okay, so let's say you want to graph a polynomial function. Well, the first thing you can do is apply the leading coefficient test. All right, our leading coefficient is positive 1, and our power is odd. So we know that this thing is doing something like this. It's increasing as we go from left to right. We don't know what's happening in the middle, but we'll figure that out in a minute. Now, next thing we can do is find the real zeros. And we're going to do that by factoring. So I can take a t out, and that leaves me with t squared minus 4t plus 4, which is t minus 2 squared. So we have two zeros, and one of them is repeated. Our first zero is at t equals 0, and our second one is at t equals positive 2. So there's one at 0, and there's one at 2. Okay, now we need to plot a few more points so we can figure out what's going on in between. So let's do an XY chart. Okay, let's put in -1. And sometimes it's easiest to do that in the factored form. So -1 times -3 squared is going to be -1 times 9, which is -9. So I've got a point way down here. And then let's put in 1. So that's going to be 1 times -1 squared, which is 1 times 1, which is 1. And then let's put in 3. So it's going to be 3 times 1, which is 3. Now remember, because this is a repeated even multiplicity factor, it's going to come up, touch the x-axis, and head back up again. And now we've graphed our polynomial. All right, let's turn things around. Let's say that we know what the zeros are, but we don't know what the polynomial is. So we like to write a polynomial of degree 3 that has these zeros. So basically that means that we have these factors: x minus 0, x plus 3, and x minus 1. Because I have 3 factors, I'm going to have a third degree polynomial when I multiply it all out. So let's do it. That's going to be f of x is equal to x times x squared. I'm going to do FOIL on these two now. X squared plus 2x minus 3. And my final answer is x cubed plus 2x squared minus 3x. Now that's pretty much all you need to know about polynomials of higher degree right now. So you can check on Moodle and look what the assignment is and get to work on it. Good luck, and I'll see you next week.